Welcome to another Sudoku Dicas. Video 74, XY chain. Let's start another Sudoku that will require advanced strategies to unravel. We'll begin our progressive scan by going through the candidates from 1 to 9. Candidate 1, highlighted in green. Available cells in yellow. When there's only one available cell, write the solution in blue, as seen here in block 2. This one will eliminate another candidate 1 from column 5. I use the color pink to indicate exclusions. Solution for F4 is 1. Exclude 1 from row F. In block 9, the two available cells are aligned in column 7. This is a pointing pair that eliminates another one from this column. The pointing pair will be noted in lilac color. In blocks 4, 6, and 7, only two cells remain for candidate 1. Note them in gray. Candidate 2, aligned in block 5, which forces candidate 2 to go to column 4 in block 8. In block 3, it can go to two cells. Candidate 3. There are many available cells. Candidate 4. In block 8, it can go to the top row. We discovered another pointing pair. Exclude it from the rest of the row. Candidate 5. There are many available cells. Candidate 6. Aligned in column 4 and column 7. Exclude it from column 7 in block 3 and note it in the remaining two cells. They are also aligned in row D. Candidate 7. Only one cell in block 1. Solution for A2 is 7. In blocks 2, 8, and 9, it can be inserted into two cells. The candidates, 4 and 7, form an exclusion pair in block 8, which excludes any other 4 or 7 from this row. Thus, in block 9, candidate 7 can only go to J9. Candidate 8, only one cell in block 1. Exclude it from this column. In block 8, there is also only one cell left for candidate 8. Solution for H5 is 8. Which, in turn, will eliminate another 8 from this row. Thus, in block 9, candidate 8 goes to J8. And in block 6, candidate 8 has to go to the right column. In block 4, candidate 8 has to go to the center column. Candidate 9, only once in the grid, but the exclusion pair, 4-7, in lilac forces candidate 9 to go to the left column in block 8. Noted. Highlighted block 8, we have two exclusion pairs, 4-7, and 2-9. So only one candidate is left to complete the block. And the missing candidate is 5. Let's update the grid. After inserting this 5 in block 8, candidate 5 can only go to the bottom row, in the yellow cells. And in block 5, candidate 5 can only go to the center column. And in block 2, candidate 5 has to go to the left column, forming another exclusion pair with that 6, in the yellow cells. In block 1, candidate 5 has to go to one of the green cells, forming a pointing triple, which eliminates a 5 in block 7. Thus, in block 7, candidate 5 goes to the yellow cell. Performed a scan with the candidates from 1 to 9. Faced with the intersections of blocks, rows, and columns and used the Snyder notation to reach this point. Now let's look for well-populated shelter cells, such as the yellow cell in D6. Note that it can only be occupied by candidate 9. This is called the last hidden candidate. The exclusion pair 4-7 completes column 6. The yellow cell in H9 can also only receive one candidate. It can only accommodate candidate 2. Having discovered this solution, we can exclude 2 from the pink cell and confirm 2 in the yellow cell. And candidate 6 can only go to the blue cell in block 3. In block 9, candidate 4 can only go to the yellow cell. In block 3, with candidate 4 excluded from the pink cells, it must go to the yellow cells. In block 6, 4 goes to the central column. In block 9, there is only one cell left to accommodate candidate 3. In block 7, candidate 3 must go to the bottom row. In block 3, 3 goes to the yellow cell. And in block 1, 3 goes to the bottom row. I highlighted the exclusion pairs. But we still have to fill in the rest of the grid. In block 5, we have 3 empty cells and lack candidates 2, 3, and 5. The blue cells are already defined. The exclusion pairs are annotated in colored sets. The yellow cells are under analysis. In block 2, candidates 4, 7, and 9 are missing. In block 3, candidates 4, 5, and 9 are missing. In block 1, candidates 3, 4, 5, 6, and 9 are missing. In block 7 to 1, 2, 3, 6, and 9. In block 4 to 1, 2, 3, 4, 6, 8, and 9. In block 6 to 1, 2, 3, 4, 5, 8, 9. Here is our grid fully filled with the possible candidates. I highlighted a clue. Can you identify what clue it is? Did you notice that candidate 3, in the highlighted column, only occurs within block 4? In other words, candidate 3 in block 4 is restricted to the highlighted column, so we can exclude it from the other cells in this block. The easy part is over. Try to progress from this point and you will see that without resorting to advanced techniques, you won't get any further. I chose this Sudoku because it will require you to know XY chain. I have already covered some videos on this topic. XY chains are based on searching for exclusions of candidates through the analysis of bi-value cells, cells that contain only 2 candidates. Since there are only 2 candidates, one being true, existing, the other will not exist, and vice versa. I will construct 2 sets, the blue set and the red set. See the construction of the sets. Beginning of the chain in the yellow cell. If one exists, it will be in the blue set. If one doesn't exist, the number that will exist in this cell is 3. So I'll put 3 in the red set. Let's continue building the chain. Now I selected the orange cell. Why did I select this cell? Because it's the only cell in this column that accommodates the other candidate 1. So, if the blue one exists, this other one cannot exist. That's why I'll put this one in the red set. And this 4 will be placed in the blue set. only one cell left for 5 in block 1. 4 and 9 form an exclusion pair within block 1. They cannot be in the yellow cells, reduction within block. New stumbling point, another XY chain. Let's build the red and blue sets. B3, red 9 blue 4. E3, red 4 blue 1. H3, red 1 blue 6. G2, red 6 blue 9. Any 9 that can see both endpoints will be eliminated. The 9 in the pink cell is in the same unit as the red 9, column 3, as well as in the same unit as the blue 9, block 7. It will be eliminated. New bottleneck. I highlighted D1 in yellow. Pause the video and try to figure out where this XY chain is and who we can eliminate. Building the XY chain. D1, red 1 blue 6. C1, red 6 blue 3. C3, red 3 blue 6. H3, red 6 blue 1. Our chain starts with the red one and ends with the blue one. So, if there is any candidate 1 that can see both endpoints, it will be eliminated. Notice that the pink cells contain candidate 1 that can see both endpoints. Update the grid. With this example, we had the opportunity to review 4 XY chains. I hope I'm contributing to your learning in the study of Sudoku logic.